energy. We have the electromagnetic spectrum. We're utilizing a part of it for actually a part of the spectrum that actually we utilize for the panels. We're taking those panels and we're taking the solar energy and we're converting it through electric energy. All right? And practically, the part of we're taking visible light, infrared, ultraviolet, and a little bit of something else. Some of the advantages and disadvantages are related to solar energy. Obviously, some of the disadvantages with depending on the sun. And actually, there are three conditions that defines as a good solar system. One being what? What is it? Come on. How much sun we have? What's the other one? How much area we have? And what's the third one? What? The efficiency of the panels, okay? So typically, if we look at the sun, we get a certain amount of what? Of the solar energy that reaches the earth, and then part of that we can use. It's sort of calculated that the amount of solar energy that you can get for one day in New York City, you can power the city for a whole year. So if you can really find a way that we can capture the solar energy for one day, you can store or utilize it, you can really power the city for a whole day. I mean, for a whole year. So that's one of the calculations. I know it sounds a little bit far-fetched for you, but there's a lot of energy coming out of the sun. All right, so if you look at through from the review, the sun being approximately about 6,000 degrees, it emits a lot of watts per cubic meter. Okay, a lot of watts per cubic meter. So it's actually but in order to reach the earth, you have all kinds of problems up there. So approximately you're getting what? Approximately about 1372 watts per square meter, which for some of you who are actually into the air conditioning business and likes the BTUs, somebody had asked me the other day, talk to me about BTUs because I don't need about watts. So it's about 435 BTUs per hour square foot, okay? A normal consideration. Now for our practical applications, what are we using? What's the standard wattage that we're using as our standard? What is it? What is it? Watt hours? No. How much actually? What is our standard watt per square meters that we use for our practical application for our solar panels? What are they rated at? 1,000 watts per square meter is the actually standard condition that we're using. Okay. And actually, we said that what's very practical is how straight or how perpendicular the sun shines the surface. And we said that the angle is important too. And another consideration that we said it was actually what? The air mass associated with that. So that some of the things that we learned before. Just for a review, the solar radiation or the flux depends what? On the latitude, okay? The length of the path and the climate, how really good of a climate that we have. This is one of the biggest considerations that we have, okay? What is a panel is made out of photovoltaic cells that actually, which is what? A semiconductor device that takes solar radiation and changes into what? DC current. DC current, okay? The radiation comes usually from the sun. That's why we call them solar cells. If you put solar cells together, you build what? A module. You put modules together and you produce what? An array. Okay? So I'm not going to go through that. And what do we said? Here's a typical guy, one of us, who went and installed a panel like that. Is shading okay? So you thinking this guy's going to be okay? Well, apparently this is an installation that I went and I took a picture at it. Okay. So if you think this is okay, but apparently one of us was able to sell the job. Excuse me? What is it? Depends. See, one of the things is depends, because if that individual actually talked to the customer and explained the condition situation that was involved in this particular project, the customer might be happy because it's still, he's going to get some amount of what? Of solar energy for free at some point in time. But you don't know. You have 6 panels in here. 6 panels is equivalent to what? An average of 150 watts will give you what? 900 watts. And an average 900 watts will be equivalent for whatever application this particular individual had in there. So don't, but obviously we have a problem here with shading. What about this? Okay. What about this? Look where the panels are installed. Okay, it's right up there, right? This is what? Sunshade type of system, and we're waiting for a patent on that. You'd be amazed what some of this panel's been installed. So, and here's a typical, this is the simple little solar pathfinder that we have. Of course, about $300 for you guys to buy it. I'll show the other one we discussed the last time. What a typical photo, question? Any question? No? Most of the cells we said are made of what? Silicon, okay? And you alter them by doping, which is doping is what? You're adding some sort of a different type of material to a semiconductor, which is part of the impurity, and they react up there for some reason, and we're making a cell. We're not going to go through that again. The actual process is a cell, a module, and actually an array. What's one of the fundamental things that we need to keep the arrays or the modules? Forget the wires. One of the fundamental things we like to keep the, what is it? Forget the rack. What's the fundamental thing about the modules I don't like? Dirt. What else? Temperature. Temperature. We electricians, we know temperature is what? It's the biggest problem we have in an electrical system. Okay, let's go through the manufacturing. The typical representation of the actual types of semiconductors, how they put together. We saw them in the book. We don't want to go through that again. The method of operation of converting what? Actually, solar energy to electricity, known as actually the photoelectric effect. Okay, and that is nothing more than the movement of electrons within a material when it absorbs some sort of a photons and energy above a certain level. We did that, and we talked about a photon is what? Part of an electromagnetic type radiation. It has a mass and it moves and produces energy. All right, let's continue. Now, if you look it through, actually, the sun shines in here. It creates what? Current, and current flows actually through our load. Put a little switch in here. This amount of energy up there depends on what? On the size, the area, and the amount of what? Radiation that we're putting into it. Okay? You had a question? No. Okay. This is all review. We looked at the actually types of photovoltaic materials that is available, and we can see based on actual efficiencies, monocrystalline, polycrystalline, different other types that we have, and we find out that monocrystalline and polycrystalline is the ones that are mostly widely used with the practical efficiencies associated to them, which is what? 11.5 to all the way to 17. We said that this monocrystalline is what? That we utilize the most because of the manufacturing processes. Polycrystalline, again, they're good enough, but in the market, it's this. Now, I'm passing an article around that says we can utilize actually plastics to make those things. You can see there's a lot of things that we can utilize to make actually modules. The industry is there, the technology is there, it has to be what? Cost effective. Okay? I just read the other day, we got a module up here, some manufacturing, that's 285 watts. 285 watts versus 185 watts for some of the modules that we have now. It's actually a considerable amount of power that we can get out of it. Okay, gallium arsenide, you all know about the gallium arsenide. It's got a problems for it. Some of those things, for some of you who will be taking any of tests or prepare for that, I know I've been going over and over again, but you got to know what is solar radiation. What's the difference between solar insolation and solar irradiance? Okay? I know I covered it. Remember, radiation, solar irradiance is a what? It's a value of radiation that is what? It's instantaneous value.